everybody, welcome back. In this video, we're talking about wireless LAN controllers, or just WLCs for short. Now, what is a wireless LAN controller? Well, essentially, it is the same type of network node like a router or switch or a firewall or anything else that we would put on our network to help us to configure it and set it up, etc. So a wireless, a WLC is a device that we're going to scale like anything else. You can see that the first couple few here on the top, they look like firewalls. And then this guy down here looks like a firewall on steroids. At the end of the day, these are just regular devices that we're going to connect into our network, and they're going to become a centralized management point for our wireless devices. Now, I think at a concept that makes sense to you, but why do we need it? You have to understand the reason why we would want to deploy a wireless LAN controller. So in order to do that, what I want to do is I want to whiteboard out what you might run into in your home, and then we can kind of evolve that into what you would find in a corporate environment. So let's just imagine that we have a house, and that house is a 2-floor house with 4 rooms. And let's just say that our internet service provider has come in and they've deployed our wireless router in this corner bedroom down here on the first floor, right? Let's just say that this is the front bedroom to our house or something, or living room, right? Now, in this room here, you're going to get 4 bars. You're going to get a full signal because you're in the room where that wireless router lives. In this room here, you may only get 3 bars. Why? Because that wireless signal has to essentially penetrate the wall and whatever may be obstructing that wireless signal in order to get to the devices in the next room. You're going to maybe get 2 bars, maybe 3. We'll give the benefit of the doubt and we'll say 3 in the room above, because you have to penetrate not only the ceiling, so you're going to have the sheetrock above that, and then you're going to have obviously the wooden beams and the supports, and then you're going to have the plywood floor above that. So you're going to have to penetrate all of that in order to get the wireless signal up to the next floor. What's going to happen in this back corner bedroom on the opposite side of where that wireless router lives? We all know the answer. You're going to either get no bars or 1 bar. You're not going to get full signal strength. And if you get any signal, it's probably not going to, it's going to be barely usable. I have this in my own house, in my own experience, when we first moved into my house here. In fact, I'm kind of drawing my house here in the back bedroom where my master bedroom is. It's almost unusable because at the time, the one wireless router that we had just did not penetrate the walls, and you know it didn't navigate the turns. You have hallways, you have all these different kinds of things in your home, and so what happens here? You get no signal. Well, there are a couple of different ways to solve this. You could get a wireless extender. By the way, the first couple of options that I'm going to introduce to you are not really great options. They'll work, but they're not the right answer. You could get a wireless extender. Well, what does that do? A wireless extender, we're going to say EXT for extender, is going to connect to your existing wireless router. Oftentimes, these guys will be able to piggyback off of the existing wireless signal. So if you get 3 bars here, this extender will get 3 bars, and then this extender will kind of push out a signal into the next room. So you may now get a full 4 bars, but remember that you're only getting 4 bars to that extender, which only has 3 bars down to your wireless router. So you may help yourself a little bit. You may get just enough to be able to use your wireless network, but it's not going to be blazing fast. You know, you might get 1 gig down here where your internet connection starts, but you're going to get nowhere near that bandwidth speed up here. Well, especially wireless anyway, you're going to have less than 1 gig, but let's say you have 100 meg. Let's just make that more realistic. Let's just say you have 100 meg down here. Internet circuit. You're not going to get anywhere near that in that corner bedroom because a wireless extender just doesn't give you that kind of throughput. I run into this a lot in churches and like firehouses and you know, municipalities, things like that they don't want to spend a ton of money, so they go with a wireless extender, which is a little bit cheaper. You generally don't have to run any cabling, but again, it just doesn't scale to the way that you would need to, not only in your house but especially in your corporate environment. So what's another option? Well, let's draw our house again. We'll say our Wi-Fi router is connected down here in the same room. We can get a second router and we can connect it up here. So let's put up here, we'll say second router, RTR, okay? Now, how would this work? Well, first of all, I would absolutely have to cable this in because wireless routers, at least today, in the time of this video, you may watch this a month from now, 6 months from now, a year from now, and they may say, hey, now we have wireless routers that do this. But today, full-blown wireless routers that would actually give you a true boost in signal and allow you to get that 4 bars, that true bandwidth up here, would have to be physically cabled into the router that lives down here. So you'd have to run a cable, you know, up the wall, through the ceiling and through the floor and connect it in. But you would solve that problem. So up here you would get all 4 bars. Down here you would get all 4 bars. And in this room maybe you'll get 3 bars, right? So all throughout your house now you have full wireless coverage. But this comes at a price. First of all, the nature of these being independent standalone wireless routers is that they are going to have their own SSID or their own wireless network that you're going to connect to. So think about, you know, you'd normally have, you know, guest, or you'd have your home network, whatever you want to call it. Now, you can hack this by giving it the same SSID. So essentially, as a device roams, or as a device connects to this wireless router first, and as you go upstairs you connect to this one second, you would be connecting to the same SSID, and so your device doesn't have to learn multiple different SSIDs. The real problem with this type of configuration is that, again, they are standalone routers, which means they're going to have their own individual network. So when you connect this wireless router, it's going to think, or it needs to know where the internet is. So this wireless router here sees its internet is out here. So it knows that inside it's going to give out, you know, your tablet is going to have an IP address of, you know, 192.168.10.10. But this wireless router is going to consider this connection here as its internet. So this wireless router is going to create a completely separate inside network, and that inside network might be 192.168.100.10 for your tablet. These cannot be the same, because this wireless router is going to it's going to need its own internal and exterior network. Now you can, and by the way, I'm sorry if I'm explaining all of this in order to explain what a wireless controller is, but in order to understand why we would want a WLC, you have to understand the complexities of how we would design this every other way. You can convert your router to be a standalone access point. What does that mean? That means that you can tell that router, and these are certain newer routers, older routers won't do this, but newer routers, you can say, I want you to act as an access point. I don't want you to act as an actual router. I just want you to be an access point. But that access point still needs to be configured. It still needs to be maintained. You still need to make sure that that access point is configured properly. And so instead of it being a router, this might be an access point, and then it will still give you a good signal. And then this problem would essentially go away. But again, these are two still standalone access points, which again is part of our main problem. So not only do we have a reachability and a scale problem, meaning we have a coverage problem, reachability, we have a scale problem, meaning, you know, we're just talking about a house. We're not talking about, you know, 100,000 square foot office or, you know, warehouse that we have to provide wireless for. You know, this is not going to be an option. This is not going to be an option either. Now for your home, there is an answer to this, and this is to go with what we call a full mesh wireless system. You can do this in churches, in you know, municipalities like fire departments, things like that. In fact, I've deployed a bunch of these in some fire departments, and they work really, really well. Most of the time in like a fire department that wants to save money, I'll see a bunch of wireless extenders, and most of the time when I come in there, you know, the fireman will say, coverage is a problem. You know, we have really bad signal in certain bays, in certain offices, and, you know, the bedroom has terrible Wi-Fi or whatever. This is how I fix it. So you're going to have your main Wi-Fi router. And by the way, I'm left-handed, so as I'm writing on the right-hand side of the screen, you'll notice things are starting to kind of tilt this way a little bit. So we still have our main wireless router that lives in this corner office, right, where the internet comes in. We're still going to put an access point up here, but that access point is going to be connected into the main router. If you go to Netgear's website, you can look up Orbi. This is a great example of this system. In fact, you can watch some videos on how the Orbi works, and it's a great solution not only for your home, but also for small businesses. So this access point is going to get connected into this router, and it acts a lot like a wireless extender where it can still connect into that wireless signal. So I can tell that access point, hey, I want you to connect into here, and I want you to give a signal boost for the devices that are in here. Now that does still come back to this problem here where I could get 5 bars or 4 bars in this room, but only 3 bars here. But if I physically cable it in, this access point now becomes a full access point, similar to having a full router over here. The difference is that these are no longer standalone, meaning this wireless router now controls this access point. So as I roam from device to device, my IP address is going to remain 192.168.10.10. I'm not going to disconnect. If I go with this solution here and I actually use a router and not an access point, then as I go from one router to the other router, I'm actually going to disconnect off the network, which means, you know, streaming video is going to be impossible. The video connection is going to cut. Being on a conference call or something like that, that's not going to be possible because that's going to get cut off. And so with this kind of mesh system, it gives me the ability to have everything managed by a main central brain. That brain not only manages the devices that are connected to it, not only does it manage the devices that are connected to it, but it also manages the amount of access points that I have. So if I wanted to put another access point over here to make sure that, you know, maybe this guy's physically cabled in and this guy's just going to do a wireless connection off of it, you know, now I'm really getting full coverage throughout my entire house or my entire facility, but it's all being managed by this central brain. So not only does it manage the devices again, but it also manages the channels. So one of the things that you're going to learn about wireless, or I hope that you go on to learn about wireless that's outside the coverage of this course, I think, are the different channels. So all of these access points have to operate on their own channel, and those channels cannot overlap. If they overlap, then the access points are actually going to interfere with each other, and you could find a scenario where the access points are actually kicking themselves off the network, and you're not going to have access. The same thing with the signal strength. So you don't ever want an access point to be sending strong signal this way and this one's sending such a strong overlap. You want them to overlap, but you want them to overlap something like, you know, this, where they all have that's a bad example. They all have a coverage area where there's no gaps, but they don't overlap to where this signal's all the way over here and it kind of encompasses the other signals. And so with a mesh system, the main central brain is going to manage all of that for you. And this is exactly why we have wireless controllers. So if I draw a real network that you might see, you're going to have your wireless LAN controller. Now this is going to be ×2 at minimum, because you're going to want 2 different wireless LAN controllers, again, that are to scale. If you're going to have, you know, 10,000 users and you're going to have, you know, 500 access points, you want to make sure that both wireless controllers can handle that. They're going to be connected to each other and probably have, you know, some kind of switch in the middle. Now, both wireless LAN controllers are going to be connected to a switch. Doesn't have to be the same switch. It can be a different switch as long as those switches are connected. By the way, I'm drawing you somewhat of a normal network topology that this way you understand how this works. In fact, let me grab the eraser here and let me erase this line here so you know how this works. So these wireless LAN controllers can communicate with each other through the switch that they're connected to. Sometimes they do have their own failover cable that's kind of connected between the two. And then off of those 2 switches, you're going to have many more switches. So you're going to have all of these different switches in your environment, and this is going to be where you have your different users. So you're going to have your laptops and desktops connected. You're going to have your IP cameras. You're also going to have your access points. Now again, based on the 2 different options that I should say the 3 or 4 different options that we were reviewing about your house, normally without a WLC, you would have to go into each one of these wireless, each one of these APs, and you'd have to manually configure each one with the same SSID, with the same password, and then as a corporate user was moving around the office and they were leaving this access point, they would disconnect from the network and they would connect to this one, and so on and so on and so on. Even if they shared the same IP address, even if you had a DHCP server sitting back here that was giving them the same address each time because they were all on the same network, they would still be disconnecting. So with a mesh system, with a wireless controller, that user can essentially walk all the way through this environment and even maybe outside into a different building, and the wireless LAN controller will make sure that they roam through the entire system. So as the signal strength gets weaker from this access point, they will automatically connect to the next access point that's in line, and the wireless controller will manage all of that for you. You won't have to visit each access point. Essentially, the only thing you'll have to do is tell the access point to connect back to that wireless LAN controller, and then once you do that, this is where you're primarily going to log in and do all of your administration. Now, the other thing, and I want to start cutting this video just a little bit quicker because I know we're already at 15 minutes, is looking into Meraki. Now, depending on the kind of environment that you have, Meraki is also a good option. Meraki is a cloud WLC. So it still acts exactly the same as this WLC connection here, but all those access points are going to be connected out to the internet, and then your cloud portal is going to give you access to those access points. So essentially, rather than making sure everything's cabled up correctly, you can just have those access points, they get out to the internet, and then you configure everything through your Meraki portal. So this is the benefit to having a WLC. This is the reason why we have wireless LAN controllers. It solves our scalability problem, it solves our coverage problem, it solves our roaming problem, it solves our manageability and configuration problem. A WLC is really, in any type of large corporate network, what you really need to deploy. Hope you guys enjoyed this video. See you all in the next one.